All right, here we are, the very last skill for unit, what are we, 6? It's all about the natural logarithm. Okay, now be careful because sometimes we tend to think that, oh, this is something so different. And everything that we have been practicing up until this point, nothing changes. The only thing that changes is that this is a logarithm, whoopsies, with a base of e. Okay, so logarithm with base e. Now remember, e is approximately 2.7128 blah, blah, blah. And it is on the left-hand side of your calculator. So if we see ln of x, we need to know that it is equivalent to the log base e of x. We call it the natural logarithm. It is the inverse of e to the x. So if you look at the graph that we're provided here, the purple one is e to the x. Well, e being 2.7128 blah, 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 is greater than 1. So it makes sense that this would be exponential growth. And its inverse, ln of x, the natural log of x, is also increasing. Why? Because this is the same as the log base e of x, and its base is greater than 1. Okay, so all of the properties that we've talked about, they still apply. How we solve equations, they still apply. The only difference is now we're dealing with a logarithm with base e. What other special logarithm have we come across? The common logarithm, and that was base 10. Okay, so the only difference here for skill 8 is that this is going to be base e. Sweet, let's do it. Rewrite, for example 13, each expression as a single logarithm. Okay, when we're rewriting as a single logarithm, we always want to use the power property first. And in example A, I see that we can put the 3 as an exponent on the 2, and then we have minus the natural log of x cubed. Simplify with me a little bit, please. So 2 cubed is 8. We have the natural log of 8 minus the natural log of x cubed. Since they're being subtracted, we can use the quotient property, combine them. Remember, the first term is always the numerator. So we have the natural log of 8 over x cubed. We can't evaluate this term or this expression because it has a variable in it. It doesn't make any sense for us to evaluate, so there's our final answer. For 13b, again, I'm definitely going to use my power property first. So we have the natural log of 3 squared plus the natural log of 8. Again, let's simplify. So the natural log of 3 squared is 9 plus the natural log of 8. And since it's being added, we can use the product property. So we have the natural log of 9 times 8, which is 72. Now, if we could evaluate, remember, evaluating a logarithmic expression, we're finding the exponent. So our base is e. E to what power is 72? That's what we would be looking for. Without a calculator, I don't know. So I'm not evaluating this. I'm going to leave it as the natural log of 72. Okay, and then the last one, let's go ahead and use, again, our power property first because we were asked to write this as a single logarithmic expression. So we have the natural log of x to the 20th power plus the natural log of y to the 5th minus the natural log of z squared. Working from left to right, just like we'd read a book, I'm going to combine x to the 20th and y to the 5th. Now, these two logarithmic expressions are being added, so we can say that this is the natural log of x to the 20th times y to the 5th minus the natural log of z squared. Continuing to combine, now I have two logarithmic expressions that are being subtracted, so taking that first term and putting it in the numerator, we have the natural log of x to the 20th, y to the 5th, all over z to the 2nd, and that's our final answer because we can't reduce anything. Okay, so again, the properties are still the same. We're just dealing with base e. Okay, example 14, let's solve For A, it says the natural log of x is 5. Well, I have one logarithm equal to a constant, so immediately I'm thinking I'm going to need to rewrite exponentially, but maybe I struggle with the base since I can't actually see it. You're more than welcome to rewrite the natural log as the log base e if you need that visual, okay? So then from here, let's rewrite it. Well, e to the 5th, okay, base exponent is equal to the quantity of x. X is e to the 5th. And we'll leave it as such. Yes, it's a logarithmic equation, so we need to check our answer, but we know that e is positive. If we raise it to the 5th power, it's still positive, so our answer is okay. It won't make this quantity negative by any means. Okay, for B, again, same situation. I'm going to rewrite the natural log as the log base e of this quantity so that I can see, oh, I'm dealing with base e. My only option, since I have one logarithmic term equal to a constant, is to rewrite it as e to the 3rd power is equal to 6x plus 1. Now let's go ahead and isolate x. We're trying to solve for x, so I'm going to subtract 1 to both sides. We get 6x is equal to e to the 3rd minus 1, and then divide by 6, so x is equal to e to the 3rd minus 1 all over 6. Now, before we box our answer, we need to check it. E is positive, right? It's 2.7. If we cube that, we get a number that's bigger than 1. So when we take 1 away from that, we will get a positive number. Remember, we have to check that this quantity does not become negative. Here it does not, so we are absolutely okay. All right, let's take a look at C. We could bring the 2 down in front. Or we could just rewrite it into, yes, let's rewrite it into exponential form. So we have the log base e of 2x plus 1 squared is equal to 6. So we have e to the 6th is equal to the quantity of 2x plus 1 squared. Now, yes, we could absolutely square out this quantity, but I don't know what e to the 6th is without a calculator. And I don't want to use a calculator, and you're not really... The idea behind this skill is to not use a calculator. So let's take the square root of both sides. In doing so, we get 2x plus 1 is equal to. Think about what the square root of e to the 6th represents. I could rewrite this as e to the 6th to the 1/2 power. Power raised to a power, we get e to the 3rd. Now, you could also think of it as, well, if I'm taking the square root of e to the 6th, how many groups of 2 can you take from 6? 3. So we get plus and minus, don't forget your plus and minus, e to the 3rd. Okay, continuing to solve, we get 2x is equal to negative 1. We're going to subtract 1 to both sides, plus and minus e to the 3rd. I like to have my plus and minus in the middle of my expression, so that's why I just put the negative 1 in front. And then when we divide, we get x is equal to negative 1 plus and minus e to the 3rd all over 2. But we're not done because we need to check our answer. Now, the saving grace is that we have a square, and the square is what's given to us at the very beginning. It wasn't written in front and then we moved it up. None of that happened. So since the quantity is squared from the get-go, this is our solution set. We don't have to worry about the minus and making that quantity negative because it's always going to be squared. Okay, so our last example is example 15. These are the exponential equations. We don't have to check our answers. And thankfully, on this first one, our exponential term is isolated. So we can go ahead and write the log base e of 24 equal to x plus 3. Now, yes, normally for exponential equations, you want to get the bases to be the same. There's no way I'm getting e and 24 to have the same base. So immediately I chose to write it into log form. And to get us comfortable with the formatting, I am going to change log base e to the natural log of 24 equal to x plus 3. And then To isolate x, we just subtract 3, so x is the natural log of 24 minus 3. Final answer. Notice I said at the beginning that it was isolated. If we look at b, this exponential term is not isolated. You always have to isolate the exponential term before you solve for the exponent. So dividing both sides by 5, we get e to the negative 3x is equal to 9. Okay, rewriting in log form, we get the log base e of 9 equal to negative 3x. And again, to get us comfortable with the formatting, I'm going to change this to the natural log of 9 equal to negative 3x. Last step, divide by negative 3, so x is the natural log of 9 divided by negative 3. And that's our final answer. Again, we don't have to check our answers, our solutions, because exponential functions don't have any restrictions on the domain. You can substitute any number in for x and you'll get a corresponding output. Last but not least, there's a couple items we need to move. Have to isolate the base, ladies and gents. So I'm going to add 8. So we get 2e to the 5x power is equal to 38. And then divide by 2. So e to the 5x is equal to 19. Now that we've isolated the base, that exponential term, we can put it into log form. So log base e of 19 is equal to 5x. Writing it in the proper format, we have the natural log of 19 is equal to 5x. And divide by 5. So x is the natural log of 19 all over 5. I'm not putting it into my calculator ever, because we don't want to approximate. We want our answers exact. All right, see, nothing changed. We're just dealing with base e. That is our natural log.